Good morning everybody and welcome to today's worked exam answer video. Today I'm taking a look at a structure and bonding question which might appear on both the AS or the A-level AQA papers. In this particular question we're focusing on shapes of molecules as well as types of bonds and how those bonds are made, and we are specifically focusing on that reaction there between the boron trifluoride and a fluoride ion. As always, I will highlight all the key information that we are asked to include in our answers. I will then write a model answer and I will explain that to you as well. Okay, so here we go. We need to draw diagrams to show the shapes of both the BF3 molecule and the shape of the BF4- ion. In both cases, we have to name the shape and then we have to account for the shape of the BF4- ion and state the bond angle present. So even though this is worth 6 marks, the question is quite clear in where those marks are going to come from. So first thing I did was I drew my shapes. So the way that I draw my shapes is I look at my central atom, which is boron, and I find boron on the periodic table to find what group it's in. So boron is in group 3, and that tells me that boron has 3 electrons that it can use in forming bonds with other atoms. In each of these boron-fluorine bonds, the boron is sharing 1 electron and the fluorine will be sharing 1 electron back. This gives me 3 bonding pairs. There are no more electrons that boron has, it only has 3 and it's using 3. So therefore there are no lone pairs and only 3 bonding pairs. And every time we have a shape with 3 bonding pairs and no lone pairs, it will be trigonal planar. In the BF4- example, because we have the negative charge, I would add that on to the number of electrons boron has. So if you ever have a negative charge, we're adding electrons. If it was a positive charge, we'd be taking them away. So boron did have 3, but with the negative charge, it now has 4. It is sharing 1 electron with each of the 4 fluorines. And therefore it's using all of the 4 electrons that it has. So again, there are 4 bonding pairs and no lone pairs. And anytime we have that combination, the shape will be tetrahedral. The bond angle of our tetrahedral shape is 109.5, which we're also asked for. And when it says account for the shape, it wants you to be thinking about electron pair repulsion theory. So we don't have any lone pairs here. So there's no bonding pair, lone pair repulsion. There's certainly no lone pair repulsion. When you only have bonding pairs, all of those bonding pairs of electrons will be repelling each other equally, so that the bonding pairs are as far apart as they possibly can be. And around our tetrahedral shape, the furthest apart they can get is 109.5 degrees. So that is why the BF4- ion has that shape. 4 bonding pairs, no lone pairs, all the bonding pairs repel each other equally. In the second part of the question, we're thinking about what type of bond is formed when BF3 reacts with F-. Now, we've got to be familiar with the fact that boron in BF3 is actually electron deficient. So coming back to this shape here, we have an outer shell of boron with the 2 electrons from this bond, the 2 electrons from the top fluorine bond and the 2 electrons from this one here. That only gives boron an outer shell of 6. And I know I'm using sort of GCSE language here, but the outer shell requires 8. So boron is electron deficient. And if we then look at what the BF3 is reacting with, the fluoride ion is definitely not electron deficient. That has a lone pair. It has a few lone pairs. And anytime we have something that's electron deficient and something with a lone pair, we need to be familiar with the fact we're going to get either a coordinate or a dative covalent bond. Whichever terminology you prefer is fine. It wants us to explain, in terms of the electrons involved, how that bond is formed. So it is the species that has the lone pair, which in our case is the fluoride ion. Whatever that is going to donate a pair of electrons to whatever the thing is that is electron deficient. Now notice in my answer I've said that the F- ion donates a pair of electrons, I should say, to the electron deficient boron atom in BF3. it is really important that we don't just say that the electrons are donated to the BF3. You have to specify which atom it is within the BF3 that is electron deficient. So in our case, it's boron. Likewise, if you've got an atom with a lone pair that's a part of a molecule or an ion, I'm thinking ammonia, NH3, you would say the lone pair of electrons on the nitrogen atom in the ammonia, which is donated to whatever it might be. Hopefully that's been useful, but as always, any questions, please feel free to leave me a comment on social media, YouTube, or drop me an email. Again, if we've got any requests for specific videos, please do not hesitate to get in touch. Hope you all have a lovely day. Thanks, guys.